the onion empire of Imperial Valley. Did you know that 9.8 billion pounds of onions are harvested in the US every year? That's enough to fill 1,800 Olympic-sized swimming pools. And the heart of this massive operation lies in Imperial Valley, California, a region responsible for over 80% of America's onion supply. But how do farmers turn tiny seeds into the crisp, flavorful bulbs we see in grocery stores? The answer? A jaw-dropping mix of cutting-edge machinery, precision farming, and meticulous processing. From high-tech seeders to automated harvesters that replace 50-plus workers, this is modern agriculture at its finest. In this deep dive, we'll uncover every step of the onion farming process: planting, growing, harvesting, and processing, revealing the mind-blowing technology that makes it possible. Plus, we'll explore the health benefits of onions and why they're a global superfood. What you're about to witness is the story of onions like you've never seen it before. From the sun-scorched fields of California to the icy edges of Idaho, join FactoryX as we dive into the unseen world of America's onion industry. You'll see how these crops are planted, harvested, cured, and cleaned by machines that operate with surgical precision. And the most surprising part? This entire operation happens under the constant threat of total failure. Because in the world of onions, if you're not perfect, you're out. Ready to see how your favorite kitchen staple goes from field to fork? Let's dig in. Planting the seeds, precision farming at its best. The perfect start, timing and technology. The journey of every onion begins with a perfectly timed, high-tech planting process. And in Imperial Valley, California, farmers don't leave anything to chance. The planting window is crucial. Too early, and the cold soil stunts growth. Too late, and the scorching summer heat ruins the crop. That's why from late February to early March, when the soil temperature hits the sweet spot, around 50 to 55 degrees Fahrenheit, massive automated onion seeders roll into action. These aren't your grandpa's farm tools. They're laser-guided, GPS-equipped machines that plant thousands of seeds per hour with surgical precision. Here's how they work. Precision spacing. Each seed is placed exactly 15 centimeters, 6 inches, apart in perfectly straight rows. This ensures every onion has enough room to grow without competing for nutrients. Depth control. The seeder adjusts planting depth on the fly, burying seeds just half an inch deep, the ideal depth for quick sprouting. Too deep, and the seedling struggles to break through. Too shallow, and the roots won't anchor properly. Speed and efficiency. A single machine can cover 1 to 2 hectares, 2.5 to 5 acres, per day, 10 times faster than manual planting. That means an entire field can be seeded in just hours, not days. But the tech doesn't stop there. Smart sensors constantly monitor soil conditions, adjusting planting patterns in real time to account for moisture levels and soil density. If a patch of ground is too dry, the seeder automatically increases seed density to compensate. If the soil is too compact, it lightly tills the area before dropping seeds. Drip irrigation, watering with surgical precision. Once the seeds are in the ground, the next challenge is keeping them hydrated without wasting a single drop of water. In California, where droughts are a constant threat, farmers rely on drip irrigation, one of the most water-efficient systems in agriculture. Here's why it's a game changer. Targeted watering. Thin tubes run along each row, dripping water directly onto the roots. No overspray, no evaporation. Smart scheduling. Soil moisture sensors trigger irrigation only when needed, preventing overwatering, which can rot seeds, or underwatering, which stunts growth. 60% less waste. Compared to traditional sprinklers, drip systems cut water usage by more than half, a critical advantage in drought-prone regions. Farmers also inject liquid fertilizers directly into the irrigation lines, delivering nutrients straight to the roots. This fertigation method boosts growth rates while reducing chemical runoff, making it both high-yield and eco-friendly. From seed to sprout, the first critical weeks. Within 7 to 10 days, the first tiny green shoots push through the soil. This is when farmers switch into high-alert mode, patrolling fields daily to catch any issues. Pest patrol. Onion maggots and thrips love young seedlings. Farmers deploy pheromone traps and organic pesticides to keep them at bay. A disease watch, fungal infections like damping off disease, can wipe out entire rows overnight. Preventive sprays and well-drained soil are key defenses. Growth checks. If a section is sprouting unevenly, farmers replant immediately. Every lost day means a smaller bulb at harvest. By week 4, the plants are strong enough to thrive on their own, with leaves stretching toward the sun and bulbs starting to form underground. From here, it's a race against time, just 90 to 120 days until harvest. Why this process matters? This military-level precision isn't just for show. It's what allows U.S. farmers to produce 9.8 billion pounds of onions annually. Without these high-tech seeders, smart irrigation, and constant monitoring, yields would plummet and prices would skyrocket. Next time you chop an onion, remember, its journey began with a machine planting it in the perfect spot, at the perfect depth, with the perfect amount of water, all before it even sprouted. The harvest, 10 tons per hour, inside the world's most advanced onion harvesters. Harvest season, when Imperial Valley turns into an onion gold rush. Picture this, thousands of acres of plump, golden onions, their green tops swaying in the California breeze, ready to be pulled from the earth. But here's the catch, they have just a 2-week window to harvest them all before over-ripening ruins the crop. That's where the Grimm Veritron 270 comes in, a $500,000 harvesting beast that's basically the Ferrari of onion farming. This isn't just a machine, it's a fully automated, AI-powered harvesting factory on wheels. And what it can do in a single hour would take 50 farm workers an entire day. How it works: step-by-step onion extraction. Step 1. Undercutting the bulbs, the gentle uproot. Instead of yanking onions out, which bruises them, the harvester glides a flat blade 2 inches under the soil, slicing the roots cleanly while lifting the bulbs in one smooth motion. Vibration sensors adjust blade depth in real time, deeper in dry soil, shallower in wet, to prevent damage. Step 2. Dirt removal, the high-speed shake. The onions hit a shaking conveyor belt that vibrates at 1,200 RPM, blasting off dirt without harming the skin. Air jets then blow away leftover debris, leaving bulbs spotless before sorting. Step 3. Top and root trimming, precision surgery. A rotating blade system slices off dried tops and roots in 0.2 seconds per onion, faster than a human eye can blink. The waste gets recycled as compost, while the trimmed onions roll toward inspection. Step 4. AI sorting, the rejection game. High-res cameras scan each onion at 60 frames per second, checking for cracks or bruises. Infrared detects internal damage. Size: rejects undersized bulbs under 2.5 inches. Shape: oddly shaped onions get kicked to the processing pile. Pneumatic arms flick defective onions into a separate bin, 200 decisions per minute. Step 5. Loading the hull, final countdown. Only grade A onions make it to the 1,000-pound bulk bins, which are forklifted directly onto waiting trucks. From field to truck? Less than 5 minutes per load. By the numbers, why this machine changes everything. 10 tons harvested per hour versus 1 ton manually. 1.5 hectares, 3.7 acres, cleared per day. Less than 2% damage rate. Manual harvesting loses 10 to 15% to bruising. 0 labor shortages. 1 operator replaces 50+ workers. The secret behind the speed: twin engines and smart tech. Dual diesel engines, 500 HP total, power both movement and processing. GPS auto steering keeps rows straight within 1-inch accuracy, avoiding overlaps. Live yield tracking sends data to the farmer's tablet in real time. Field 14, 8.2 tons/HR, 92% grade A. What happens to the rejected onions? Even the discards don't go to waste. Cracked/damaged onions processed into diced, frozen, or dehydrated products. Oversized bulbs, too big for retail, sent to restaurants or salsa manufacturers. Why this matters for your grocery bill? Without these harvesters, onion prices would double overnight. Manual harvesting costs $150 per ton. The Grimm does it for $30. That savings helps to keep supermarket onions around $1 per pound despite inflation. Processing: inside the high-speed onion factory, where 2 tons per hour become slices, rings, and powder. From truck to table in 90 minutes. The assembly line you never knew existed. The harvest is just the beginning. Within 1 hour of leaving the field, onions arrive at processing plants where they undergo a metamorphosis, from dirty bulbs to supermarket-ready slices, restaurant-grade diced pieces, or even instant onion powder. This isn't just a factory, it's a food engineering war room where lasers, steam jets, and robotic arms work in perfect sync. Let's break down the 5-stage transformation. Stage 1, the 60-second unloading and first cut. Trucks dump 20,000 pounds of onions onto a vibrating conveyor that spreads them into a single layer. Workers do a final manual inspection, tossing any onions with hidden rot. AI can't catch everything yet. A guillotine-style cutter lops off the top and bottom of each onion in one swing, no more papery husks. Fun fact, the trimmed ends get boiled into vegetable stock, zero waste. Stage 2, the blazing hot peel. No human hands touch these onions. Onions ride into a 30-foot-long steam tunnel, 200 degrees Fahrenheit, 93 degrees Celsius, for 12 seconds. The heat loosens skins without cooking the flesh. Next, they hit spinning rubber rollers that rub off the papery layers like a high-speed exfoliating spa treatment. UV scanners check for leftover skin. If any remains, the onion gets recycled through the peeler. Stage 3, the slicing matrix, where blades move faster than a Formula 1 pit crew. Customer demand decides the cut. Hamburger rings, 8 millimeters thick, fast food chains. Brunoise dice, 3 millimeters cubes, fancy restaurants. Julienne strips, stir-fry kits. Tungsten steel blades slice 1,000 onions per minute with 0.1 millimeters precision. The machine auto-adjusts for bulb size. Nitrogen gas floods the cutting chamber to prevent oxidation. That's why store-bought slices stay white for weeks. Stage 4, the dehydration dome, where onions become space food. Some onions take a detour into 10-story drying towers. 60 degrees Celsius, 140 degrees Fahrenheit air flows upward as slices cascade down stainless steel tiers, like a giant onion waterfall. In 4 hours, they shrink to 10% of their weight, becoming crispy chips ready for soup mixes, seasoning blends, astronaut meals. NASA loves dehydrated onions for ISS missions. Stage 5, the packaging robots, faster than Amazon's warehouses. Lasers weigh portions to the exact gram, no half-empty bags. Vacuum sealers suck out oxygen, extends shelf life to 2 years without preservatives. Robotic arms palletize 50-pound boxes at 40 boxes per minute, labeled for Walmart USA, Tokyo ramen shops, Japan, McDonald's, global ketchup suppliers. By the numbers, why this factory is smarter than your car. 2.5 million pounds processed weekly, equivalent to 5 statues of liberty in onions. 3% moisture variance across all dehydrated product, NASA-level precision. 0 human contact from peeling to packaging, hygiene score, 99.99%. The hidden hero, the workers you don't see. Onion whisperers calibrate machines daily using odor sensors. Yes, they track pungency levels. Fluid dynamics engineers optimize airflow in drying towers to save $500,000 per year in energy costs. Taste testers sample batches hourly because machines can't detect off flavors yet. What this means for you. That pre-diced onion tub at the store? It was likely cut within 48 hours of being in the ground, fresher than most whole produce. And thanks to this tech, food waste dropped by 40% versus old-school methods. Global journey, from California fields to international plates, the onion supply chain unveiled. The moment onions leave the processing plant, they embark on a logistics masterpiece, a globe-spanning journey that puts airport hub operations to shame. Here's how 9.8 billion pounds of onions annually navigate the ultimate cold chain obstacle course to reach your local supermarket with perfect freshness. The refrigeration revolution. How onions stay crisp across continents. Every shipping container becomes a climate-controlled ecosystem the second it's loaded. Precision cooling systems maintain 34 degrees Fahrenheit 1 degree Celsius with 65% humidity, the exact conditions that keep onions dormant without freezing. Ethylene scrubbers, the ripening gas bananas emit, prevent premature sprouting during 6-week ocean voyages. Smart trackers relay real-time temperature data to distributors. If a fridge fails, the entire container gets rerouted to nearest processing for quick repurposing. Pro tip: the best storage onions undergo curing, a 3-week drying process that forms protective papery skins capable of surviving 9 months in transit. Port hustle. Inside the world's busiest onion export hub. At the port of Los Angeles, onions face their first major sorting. Japan-bound shipments require extra irradiation treatment to meet strict agricultural laws. Middle East containers get double-walled insulation for desert crossings. Emergency bridge loads wait on standby ships to replace spoiled shipments mid-route. Did you know? One specialized reefer ship can carry 12,000 metric tons of onions, enough to supply every McDonald's in Europe for a week. The supermarket sprint, last-mile logistics secrets. Those neat mesh bags in your grocery store? Each represents a minor technological miracle. Robotic palletizers at distribution centers sort by destination using store-specific algorithms. Ripeness pacing software staggers deliveries so onions hit perfect edibility as they hit shelves. Antimicrobial packaging, embedded with oregano and thyme extracts, fights mold naturally. Retail reality check. Despite all this tech, stores still lose $1.2 billion annually to onion spoilage, hence the rise of ugly onion discount bins at progressive markets. The restaurant pipeline. How fast food gets its fix. McDonald's alone uses 4.5 million pounds of onions daily across 38,000 locations. Their system is arguably more advanced than some space programs. Regional prep centers receive bulk shipments for pre-processing into exact 3 mm dice. Cryo-frozen portions get sealed in nitrogen-flushed pouches that lock in flavor for 18 months. Just-in-time delivery trucks equipped with GPS spoilage predictors reroute based on traffic heat maps. Chef's secret: high-end restaurants pay 300% premiums for live onions, bulbs shipped with roots intact in hydroponic pods for ultimate freshness. The future: blockchain-tagged bulbs and AI freshness forecasts. Pioneering farms are now implementing NFT-style harvest certificates, allowing consumers to scan and trace their onion's entire journey. Predictive spoilage algorithms that adjust shipping routes based on weather pattern shifts. Self-healing packaging using nanomaterials that seal micro-tears automatically. Bonus: the dark side of onions, a tear-jerking fact. The plant's defense chemicals that make you cry? Factories capture and condense them into natural pesticides, turning tears into eco-friendly crop protection.
The incredible journey of an onion, from seed to your plate. From the high-tech planting machines of Imperial Valley to the AI-powered harvesters, the massive processing plants, and the globe-trotting logistics network, the journey of an ordinary onion is anything but ordinary. What most people see as a simple kitchen staple is actually a marvel of modern agriculture, robotics, and supply chain engineering. Every step, planting, growing, harvesting, processing, and shipping, has been optimized to deliver maximum freshness, efficiency, and sustainability. Think of it like this: your food stays fresher, thanks to precision farming and cold chain logistics. Onions today last weeks longer than they did a decade ago. Lower prices, higher quality. Automation keeps costs down while ensuring consistent, high-quality produce year-round. Less waste, more sustainability. From drip irrigation saving water to zero-waste processing, onion farming is getting greener every year. The future of onions? Even smarter. Imagine AI-powered home storage fridges that adjust humidity to extend onion shelf life. Vertical farming growing onions in urban warehouses, cutting transport emissions. Onion-based bioplastics replacing styrofoam packaging. The next time you chop an onion, remember, it's not just an onion. It's a triumph of human ingenuity. Join the conversation. Did this blow your mind? Hit like and subscribe for more deep dives into how your food is made. What's your take? Would you buy blockchain-tracked onions for extra transparency? Should more farms adopt AI harvesters to reduce labor shortages? How do you store onions to keep them fresh longer? Drop your thoughts in the comments. We read every single one. Turn on notifications so you don't miss our next episode, where we explore how garlic gets harvested at lightning speed. Thanks for watching, and we'll see you in the next one.